Now then, they're 12 volt power supplies. Yeah, quite a lot of amps. Okay, and there's two of them, and I thought, let's investigate these, see if they work. They're switch mode power supplies, obviously. Yeah, so I'll show you the label and then we'll crack on. So they're sort of interesting. Yeah, 180 to 240 volt in. Okay, 47 to 63 hertz, 9 amps. Well, 9 amps at 240 volts is 1 3/4 kilowatt. Yeah. Is that right? 4 amps? No, it's more than, it's over 2 kilowatt. Yeah, and theoretically it's supposed to give 166 amps at 12 volt. For how long, I don't know. And then it's got a 5 volt output at 2.5 amps, 2000 watts. There you go. So that's interesting. If they work, you know. Will they? I don't know. I'm not sure about, you know, if you draw 2 kilowatt at 12 volts, right? How long would this go for? How long's the duty cycle? 2 seconds? 10 seconds? I doubt if it will be half an hour. Yeah? What do you think? Anyway, what I'm going to do is I'm just going to undo the screws and see if I can take a side off or something, and just to have a look inside first before we do anything else. Yeah, and then it's the standard kettle plug, yeah, and a switch. So see what happens, eh? Make it up as you go along. Okay, small posi. Yep. No screws there. There's a screw there. And there'll be 2 under there. So I will get back to you in a minute. Okay, so that's the screws undone. And that comes off. Right, I think we need to just have a look here. I think we need more light on the subject. There we go. Hopefully that'll be a bit better. Yeah. Well, got a load of capacitors on the output stage, but they don't look like they're swollen. A couple of heat sinks, more capacitors there, transformer, choke, fan, AC in, and the board is screwed down there, there, and the 2 top corners. Well, there's no standing water in it or anything like that. Shall we just put some power into it and see what happens? I can't see a fuse anywhere. Yeah. Tell you what, let's just let's put some power in it and see if the blue smoke dragon raises its head. And it might not. You never know nowadays why things are made redundant. Yeah, they might be perfectly working order, but nobody wants them anymore. So let's just set it up, get the multimeter going and see what happens. Right, just in here, and I don't know whether you'll be able to see, "12 volt positive, 12 volt positive, ground, ground, pin 1. So I'm not sure what's going on there, but positive, positive, ground, that'll do. That was particularly useful. Okay, let's plug this in. There we go. Yep. And obviously nothing's happening at the moment. I want this on 700 volts AC. Yeah, we've got 240 volts going there. I don't want to really touch the case. Okay, we're on DC volts now. Between there and there, nothing. Yeah, precisely nothing. And it's not making any noise either, and the fan's not running. Okay. I don't know whether you can see that or not. Yeah. Yeah, nothing. Okay. But we've got 240 volts going into that socket. Oh, I can see a fuse down there. Right, let's switch this off. And switch that off. And right down there, there's a dinky little fuse. So let's just pull the plug out. Okay. Stick it on continuity and right. Oh, switch the meter on, that would be useful, wouldn't it? So the fuse is alright, but there's nothing happening there. Now, I know sometimes it could be the output capacitors that kill these things. Right, so let's try the other one. I'll be back to you in a minute. Okay, so I tell you what, let's switch it on and oh, that's interesting. 12.3. 12.26, 12.27. Right. Okay. It works. Alright. So the other one's duck, but that one's not. So a bit noisy, but for a piece of test equipment or something like that, or a charger, it's probably alright. Yeah, what we're going to do now, switch it off first. That's hell of a fan, isn't it? But then you'd want it to be like that if you're going to charge at that amount of current. How are we going to test this? How are we going to test it? We want a piece of resistance wire, don't we? And we'll have to work out what the length of the resistance wire with the ohms. Yeah, and we could use ohms wheel to sort that one out. So let me go away and sort everything out, and I'll be back to you shortly-ish. Okay, here's the ohms wheel, and let's look here. Resistance in ohms. So we've got watts divided by current squared, volts squared divided by watts, but V volts divided by amps. Okay, so we've got 12 volts. Yeah. So if we wanted to say do 500 watts, that is 500 divided by 12 gives you the current, which is about 40 amps. Okay, so then if we got 12 volts divided by 40, then that would be something like 3 12s are 36. That would be 0.3 of an ohm. Well, that's a ridiculously small amount, so and it's a lot of current. So let's test this with something like 1.2 ohms, which would be about 10 amps. Okay, gives you a bit of an idea. So let's find, I've got some resistance wire here, and some of you will be very familiar with this. It's out of the old-fashioned big storage heaters. So let's just see how much, what 1.2 ohms looks like. Right, let's do it on the floor to start with. Now, it's not going to be easy. I've got the ohms set on 2. Okay. And of course, anything will increase the resistance. Including the corrosion on the outside of the wire. That's 0.9. That's 1.2. Oh, that's not too bad. Okay, so we can bend that, and we can put that in the end, and we'll sort that out. So it's about there. Right, where are we? Here we go. So we need to squeeze that and push it in there, and that is the negative, so that will fit in there. Okay, just move this out of the way. Need a pair of pliers. This resistance wire is amazing stuff. You might have seen me use this when I was testing that big transformer, the one that was 24 or 48. Okay, so we've got that loop of wire there, yeah, across there. It's still plugged in. I've got it switched off. Right, now we want, whoop, right, we've got the clamp meter. Here we go. Stick it on amps DC. That's pretty good. And I want to put this, let me just move this, I want to put this about there, so that the clamp doesn't touch the heating surface. Right, are you ready for this? Contact! Yeah, 11.6 amps. Can you see that? Yeah. Okay. That might be quieter once we've got the top back on. But there you go. The application of Ohm's law and some nichrome resistance wire, and it tests. Now, shall I leave that on? I'll tell you what I'm going to do. I'm going to leave that on there for a couple of minutes, yeah, and just to make sure. So we'll just test it for a short while, and I'll get back to you. So, no blue smoke dragon. Sorry about that. We got one duff one and one working one. And somebody did ask me about a 12 volt power supply. And there is one. Yeah. I'm going to put the top back on just to see if that fan is quieter when it's enclosed. Alright, because I have a feeling it might very well be, because it'll slow the fan down probably. Right, back in a minute. Okay, the everything's put back together. It's still pretty noisy, but there's a lot of wind coming out of there. "12 volt power supply with a lot of current." Yeah, I reckon that's all fine. And no blue smoke dragons. There you go. Yeah. And these terminals here, they've got a screw in each. Obviously somebody's disconnected the cables, pulled the screws out, and just dropped them on the floor. Yeah. I just wonder if there's anything immediately obvious with this one. There's a screw there and one there. We have a look underneath and see if there's any burnt bits or what have you. Capacitors die, well, a duff capacitor will kill a power supply. Yeah, it doesn't have to be totally dead or blown apart. Right, have we got any? I can't see. That's undone. And that one's undone. That's also the earth. Oh, there we go. That's a soft bit of foam. So these are bits of buffer foam, but I can't immediately see any burnt bit or any damage. A lot of solder on those where they've doubled the tracks up. Yeah, lots of solder. Yeah. So that's an earth. That's earthed. So the screws are earthed, the mounting screws. So let's just turn this over. See if we can see something. Yeah. I mean, I did, those of you who watched my channel for a while, if you remember the Pod Point electric car charger that didn't work, and that was down to, there's a 12 volt power supply as a separate board in there that provides the power to make the rest of it work, and it was an output capacitor of that was killing the output of that 12 volt supply, which then stopped the rest of it working. And that output capacitor, although I changed it for, I can't remember, 1,000 microfarads, and it worked. It was a very noisy output, and I actually, what did I do? I changed it for a bigger one. Now then. Okay. I think we have mice. I think we've got mices in here. Yeah. Because that cable there is chewed off. That one there is to the, that supplies the fan, and I don't know what that one does. It says PS on. Here we go. I found it. Right. And you've probably seen it before I did. Oh. Let me just sort the camera out. There we go. We've got that IC that's split open. It's obviously overheated. So I'm not about to mess with this anymore. Yeah, and those cables there were bitten off or something, and they could have shorted together. Yeah, there you go. Right, okay, well we got 1 out of 2, and I think that's pretty good. Yeah. So there you go. If you don't investigate, you don't know, right? And there's a point where you just go, well, let's just give it a go and see what happens. And big 12 volt power supply up to 166 amps, which is absolutely outrageous. Now, if you look there, see, this wire is connected to something, whereas that other one, wherever we are, zoom out, come down here, yeah, a mouse has probably bitten it or something like that. Right, comments, discussion, tell me what you think. Yeah, that's a useful power supply. Yeah, 12.3 volts or something like that. I wonder if there's some voltage adjustment somewhere. There might very well be, but we'd have to find a little adjustable screw pot or something like that. Right, catch up with you soon. Cheers for now.